All right, so to clear something up, when resistors are put in parallel, it reduces the overall effective resistance of that parallel branch. However, the individual branches, the actual resistance doesn't decrease, right? They're a set amount. For instance, in here I have every top branch is 5 ohms. Well, regardless of how many other resistors there are or their value, that top branch will always be a 5 ohm resistance. And in this case, I am using 100 volts as my power source. And so that top branch will always have 20 amps going through it, as you see here. Right? And that's regardless of the resistor that is paired with it. But adding a second branch compared to just a single resistor, what a second branch does allow for is more coulombs per second to go through that same area. So for instance, we have the 20 as we did above here, but we also have an additional 100. We have the 20, but by adding a second branch, we have another 20. And a third one, we have 20 still, just like we did here, but we have an additional 10 amps as well. So adding a branch reduces the overall effective resistance by allowing more coulombs per second to pass. Once again, you could pause and take a look at this, but now I just did it once again by adding a third branch in. So I have my standard 5 and 1 ohm parallel branch put together with 20 amps and 100 amps going through the 5 and 1 ohm resistor respectively. And this is just showing that that will remain constant with that set voltage of 100 volts, right? We have 20 amps going through the top branch. We have 100 amps going through the middle branch. And so what adding a third branch allows is for more coulombs per second to go through, or more current, right? So depending on the resistance value will depend on how much more coulombs per second is allowed to go through. So once again, the individual branches resistance is constant. However, as a combination in a parallel display, the effective resistance is reduced because it allows more coulombs per second to go through given this constant voltage.